Hello everyone, this is lecture 3, Polar Coordinates. In this lecture, we will learn how to derive the relationship between polar coordinates and rectangular coordinates. We're going to learn how to plot points in polar plane or in polar coordinate system. And we will learn how to convert points and equations from polar coordinate system to rectangular coordinates and vice versa. Now, the first topic I would like to cover is we're going to define polar coordinate system in a relationship with a rectangular coordinate system. So in pre-calculus or calculus or algebra for that matter, you'll learn that you have the rectangular coordinate system or the xy plane or the Cartesian coordinates. It consists of two axes, the x-axis and the y-axis, and the two axes intersect at one point. That point is called the origin, and usually is called O. And there is a point on the xy plane, and that point consists of two components. The first component is x, and the second component is y. So this is the x value, this is the y value. So this is the point in the rectangular coordinate system. So x and y in the rectangular coordinate system. There's another name for that, it's called the Cartesian coordinate system or the xy plane. Now what we want to do is to convert this point to the polar coordinate system. So there's a certain situation where polar coordinate system would be more useful. For example, if you operate a vessel or a ship on the oceans, you would like to use a polar coordinate system, or you fly a plane or fly a helicopter, you would like to use a polar coordinate system to navigate around. So it's important for us to understand how to convert from Cartesian coordinates to polar coordinate system. So you see here, there's the line segment connecting the origin with the point on the xy plane, and that distance I'm going to call that r. And this line segment formed with these two sides will form a right triangle, and this is going to be y, and this is going to be x. And we're going to build the relationship between the rectangular coordinate system with the polar coordinate system as follow. So first of all, when you look at the right triangle, you can apply something called the Pythagorean's theorem. So by the Pythagorean's theorem, we have that x squared plus y squared equal to r squared. So that's one formula that connects the rectangular coordinate system with the polar coordinate system. In addition to that, the line segment right here form an angle with the horizontal axis, and that angle we're going to call that theta. So now our job is to actually write the relationship or find the formula that help us convert the point x comma y into the point r comma theta. So the point r theta is the point in polar coordinate system. So we have one equations to build that relationship. This is one equations. Another equations, some of the equations can be done using the calculations of cosine of theta and sine of theta. In addition, we have that cosine of theta is equal to the adjacent over the hypotenuse. Again, we're still considering this right triangle. This is the angle theta, the adjacent is going to be x, and the hypotenuse is r. So you have cosine of theta equal to x over r. If you solve for x, you have x equal to r times cosine of theta. And for sine of theta, this is equal to the opposite over the hypotenuse. So the opposite is y, the hypotenuse is r. So you have sine of theta is equal to y over r. When you solve for y, you get y equal to r times sine of theta. Another formula that can help us connect between the rectangular coordinate system with polar coordinate system is calculate tangent of theta. So tangent of theta is a sine of theta over cosine of theta. So sine of theta is y over r divided by x over r. When you divide up fractions, you can multiply it by the reciprocal. So you get y over r times r over x, and this is equal to y over x. Now, in order to find the value of theta, you take the inverse of tangent on both sides of the equations, and you get theta equal to r tangent of y over x. So these are the formula that help us convert from the rectangular coordinate system to polar coordinate system, where r is called the radial coordinate and theta is called the angular coordinate. Okay, now I'm going to write out the theorem, a formal theorem for converting between polar coordinate system and a rectangular coordinate system. So given a point P in the plane with Cartesian coordinate x, y, and the polar coordinates are theta, the following conversions formula hold true. So we're going to have 4 different formula. The first one is that of x equal to r times cosine of theta. The second formula is y equal to r times sine of theta. And the third one is x squared plus y squared equal to r squared. And the last formula related to tangent of theta equal to y over x. More specifically, if you want to calculate the value of theta, you do theta equal to r tangent of y over x, where our tangent is the inverse of tangent function. Okay, so we're going to use this formula to converting points from one coordinate system to another coordinate system. All right, so let me show you example 1. So in example 1, we want to convert the point 1, 1 into polar coordinate system. So this point given to you is in rectangular coordinate system x, y, and you want to convert this into r, theta. Again, r is the radial coordinate and theta is the angular coordinate. So to get the value of r, we're going to use this formula, x squared plus y squared equal to r squared, where r squared equal to x squared plus y squared, where x equal to 1 and y equal to 1. So you get this equal to 2. You take the square root on both sides of the equation and you get r to be equal to 2. I want to point out that when solving the solutions of an equation, when you take the square root on both sides of the equation, usually you obtain 2 values or 2 solutions, plus and minus. But in this case, r is a distance, so therefore I'm just going to choose the positive value. Now for the value of theta, I'm going to use this formula right here to find the value of theta. So theta is equal to r tangent of y over x, where y is equal to 1 and x is also equal to 1. So I get r tangent of 1. Now, when you calculate r tangent of 1, if you don't remember the specific value of theta when r tangent equal to 1, you can use a calculator. But when you use a calculator, you have to be careful, and even you remember this special angle, you have to be careful with this type of exercises. It's because when theta equal to r tangent of 1, there are 2 values of theta that you're going to obtain. So the first one is when theta equal to pi over 4. Why that is the case? Because tangent of theta, or tangent of pi over 4, is equal to 1. But also, in the case of theta equal to 5 pi over 4, which is in the third quadrant, so when theta equal to 5 pi over 4, tangent of 5 pi over 4 also give you 1. Okay, so how could you distinguish? You look at the given point. So the given point here is 1, 1. They are both positive value, and so therefore the point is in the first quadrant. Because of that argument, you're just going to choose the answer that is pi over 4 and eliminate the answer of 5 pi over 4. Okay, so I hope that makes sense to you. In the case where you have the value or the point to be -1, -1, then the point is in the third quadrant. There. If that is the case, then you can choose the value of theta equal to 5 pi over 4. So you have to be careful of what the point are given to you. Okay, so the point in the polar coordinate system is, so the point in polar coordinates is square root of 2 comma pi over 4. Okay. Now moving on to the next example. Here again you are given a point in the rectangular coordinate system that is x comma y, and you want to convert this into r comma theta. So to find r, you apply the formula r squared equal to x squared plus y squared, or -3 squared plus 4 squared equal to 9 plus 16 equal to 25, and therefore r is equal to +5. Now for theta, you have theta is equal to r tangent of y over x. Or in this case, you have r tangent of 4 over -3. Unfortunately, there's no special angle for this r tangent of 4 over -3. However, you could be able to determine the quadrant of this point, right? So x is equal to -3 and y is equal to 4. So therefore, the point is in the second quadrant. So this is in quadrant 2. Right. So the point in polar coordinate system is 5, comma r tangent of 4 over -3, for the angle is in the second quadrant. So the point in the polar coordinates is 5, comma r tangent of 4 over -3. Now in the last two example, we convert point from rectangular coordinate system to polar coordinate system. In the next example, we're going to convert the point from polar coordinate system to rectangular coordinate system. So here the point is given to you, that is 3 comma pi over 3. So this is r comma theta, and you want to convert this to x comma y. So to find the x value, you do x equal to r times cosine of theta, or r is equal to 3 and theta is pi over 3. So 3 times 1/2, so pi over 3 is 60 degrees, so cosine of 60 degrees is 1/2. So this is equal to 3/2. Then for the y value, you get y equal to r times sine of theta, or this is 3 times sine of pi over 3. For sine of pi over 3 is equal to √3 over 2, so 3 times √3 over 2, or this is 3 times √3 over 2. So we just convert the point 3 comma pi over 3 from polar coordinates to rectangular coordinates. So you conclude that the point in rectangular coordinates is the point 3/2 comma 3 times root 3 over 2. Okay, now let's move on to the next example. Again, in the next example, you are given a point in polar coordinates that is r equal to 2 and theta is equal to 3 pi over 2, and you want to convert this into the xy coordinates. For x is equal to r times cosine of theta, or this is 2 times cosine of 3 pi over 2. So 3 pi over 2 is 270 degrees. So cosine of that is equal to 0. So 2 times 0 is 0. For y value, you get y equal to r times sine of theta. Well, this is 2 times sine of 3 pi over 2. So sine of 3 pi over 2 is equal to -1. So 2 times -1 give you -2. And therefore, you conclude that the points in rectangular coordinate is the point 0, -2.